start, let me just do a quick introduction of who I am. My name is Ayobami Adeleke. I'll be the facilitator for this session. I am a BI developer. I'm a Microsoft certified trainer. In terms of experience, I have about 4 years experience as a BI and data warehouse consultant and developer. I've worked on enterprise projects for clients in the financial industry, in the banking sector, in insurance, in production, in manufacturing, FMCGs, and I've also had experience as a trainer for about 2 years. I've trained on Microsoft Data Platform for about 2 years. My location is Lagos, Nigeria. A few of my certifications are, I have the Microsoft Data Analyst Associate certification. I'm also a Microsoft Certified Data Engineer on the Azure Data Platform. I have my MCSA in BI Development, SQL Server BI Development, and I'm also a Microsoft Certified Trainer. So you can reach out to me on LinkedIn. My LinkedIn name is Ayobami Adeleke. Yeah, so moving forward, the agenda for today, we'll quickly touch around, we'll do a brief introduction to what we mean by relational database and workloads. We talk about the characteristics of relational data. I also walk us through different relational data structures. Here we'll be talking about 3 of them majorly, which are a table, an index, and a view. Then the last part of it, we'll talk about choosing the right platform for a relational data workload. Do you want to go cloud? Do you want to be on premise? Then a few questions and answers. All right, so the first part here is exploring the characteristics of relational data. So before we go deeper, when you talk about relational database, let me just give a quick introduction. It refers to storing data in relational structure, which is usually table rows and columns. So when you now bring it down to the database approach, when you talk about a relational database, it's more like an environment or a container that holds different entities. And when you say an entity, what do you actually call an entity? An entity is just something or a thing that you are trying to get more information about or store information of. So within a typical e-commerce database environment, entities that you usually find in such database designs would be a customer table or customer entity. You see a product entity, you have the orders entity. So all of these are the building blocks of a relational database. Entities, then entities are models as tables in the database. So on the right here, on the far left, you can see a snapshot of what a customer table could look like. You have the customer ID, you have the customer name, the customer address. So these are the bits of information about the customer that is currently saved in that structure, that customer table or entity, as it were. The information you have in an entity is dependent on the amount of information you're able to gather from your application or the amount of data you decide to store in about that entity. So it's not just going to be limited to this field. This is just a use case I'm showing here. Depending on the business, depending on your environment, will determine the number of columns that each table or entity would have. And the more attributes you have, the better insights, the better analytics you're able to do around your data. So on the far right here, we have a story. We say you design a relational database by creating a data model. The model below, okay, on the next slide, there's a model that shows the structure of the entities that we see on our left at the moment. All right, so let me just go one step ahead. So this is the model. This is what it looks like. It just creates a relationship between the different entities in your relational database. So we've seen the customer table earlier. So this is the model diagram. This is what it looks like. So let me go back to read. So in the diagram, the columns marked PK are the primary key fields for the table. Primary key is referred to or indicates the column or a combination of columns that are used to uniquely identify each record or each role in a table. It's advisable, it's best practice to ensure that all tables have a primary key. So when we say primary key, looking at the model here now, we can see our customer table. It has the primary key, which is the customer ID column. Then more attribute about the customer, the name, the address. And ideally, the primary key field is supposed to always be unique. So you should ensure that you are not having two customers having the same ID. So as much as possible during the application design and the database model design and all of that, you need to put into consideration uniqueness of values that come into the primary key field. Then looking at the others table, so the others table is more like a transactional table. So it holds real-time transactions that are happening, because remember, our use case here is more like an e-commerce environment. So there is a customer table, there's the orders table. So as they make orders on the front end of the application, it's being logged in this orders table. So you're able to see the order ID, you're able to see the customer ID, which customer is making what order, what product is being made, is being ordered in this particular transaction, and what quantity of that particular product is being ordered. So those are just the attributes of the orders table that we can see. So remember, we talked about the foreign key and primary key. So foreign keys are more like surrogate keys that you help you to reference a dimension table or a master data table from a transactional table. So what I'm trying to say here is, ideally, we have our primary key field customer ID in the customer table, but in the others table, we still have customer ID as a field, but now it's not there as a primary key, it's there as a foreign key. So it's referencing the foreign table, which is the customer table. Same thing applies for the product ID field, referencing the product table on the far right. It picks the ID of the particular product that the person is making an order for, but the orders table itself still holds its own primary key, which is the order ID. So for every order that is being made or requested on the application, on the e-commerce website or what have you, the orders are unique, their IDs are unique, and they are being logged in the primary key field here. Okay, so a few major attributes or characteristics of a relational database. The first thing to know is all data is or are tabular. So they are stored in table structures. When you talk about relational database, it's centric to tabular structures, tables basically. So you don't talk about storing unstructured data into a relational database, it won't work. So if you have unstructured database, there are other non-relational database provisionings and offerings by Microsoft that you could leverage on. But when you're talking about relational databases, you are more focused on tables, data that are stored in tables. Entities are modeled as tables, and each instance of an entity is a role in the table. So for every entity, a unique record or row, a row refers to a unique record about that entity, and each property is defined as a column. So for the attributes of that particular record, you see the attributes coming up as several columns in that table. So the columns refers to the attributes of the record, while the rows define unique records in that entity. The next point here, all rows in the same table have the same set of columns. So when you are looking at a particular table, the number of columns, the name of columns are the same for all rows. It doesn't change because it's a structured design. The same name of column, the same structure of column, and for each row. So a table can contain any number of rows. So here it's where it gets interesting. So a table, you could say a small table that has maybe just 10 records in it, and at the same time, a table can as well save up to about 50 million rows of data, depending on the kind of data being pushed and stored in this particular table. Another interesting attribute here is the primary key, which uniquely identifies each role in a table. No two rows can share the same primary key. Remember, I mentioned that earlier. The primary key has to be unique. It has to be a unique identifier that helps you to identify the particular record in that table. Then for the foreign key, a foreign key references the rows in another table, which is related to the table you are looking at the moment. For each value in the foreign key, in the foreign key column, there should be a role with the same value in the corresponding primary key field in the other table. So what we're just trying to say is that in the data model design, for every foreign key you see on the transactional table now, there must be a corresponding leg of that primary key value in the other table, which is your dimensional table or your maybe master data table. Okay, moving to the next slide. Most relational databases actually support structured query language, SQL. That's the language you use to create objects, to create entities, to load in data, to query data, and do the crude operations and basic data manipulation languages, data definition languages. All of those things, you do them using SQL. So you're able to insert, create tables, insert records, update the tables, and even delete rows in the tables. All of this you can achieve using SQL. You can also use the create table command. There's another interesting what's it called now? Keyword that you can use to create a table using SQL into a database schema. Then you also use SQL to insert records into the table. You also use SQL to update values or records that are currently populated in the table. And at the same time, if you want to delete records from a table, SQL also works for you. The select statement helps you to retrieve data. So when you want to query a database, you want to query a table in a database, your go-to guy is the select keyword. So you just do, okay, it's a typical example is what we have below here. So looking at the first query here now, we have the select customer ID and the customer name. So we are selecting customer ID, the name, and the address from the customers table. On the other end, we are picking from the orders table. We want to see the order ID, the product ID, where the customer ID is C1. So we want to now narrow down on the orders table. We want to see all the order numbers and the product IDs that customer ID C1 had raised on the system. So we are now introducing the where condition, which is just to help us filter the records and reduce the volume of data we are getting. So the third query is a bit more complex. It combines is a join between the customers table and the orders table. So we have a join between, then also a join with the product table. So now we've joined the three tables in the model to give us a more holistic view of our data set. So eventually we are selecting the customer name from the customer table. We are selecting order quantity from the orders table. We're selecting the product name from the product table. Remember, we are doing several joins. So for the first join, we're doing a join between customers and orders using the customer ID. So we have the customer ID in the customer table. We also have the customer ID in the orders table. So we are doing an inner join to give us the order quantity based on the customer ID. Then we're also doing the same join on products using the product ID and the orders table to return the product name. So the next phase here, we want to look at how do we explore relational data structures. So first thing, a relational database comprises of a set of tables. What is a table? I mentioned earlier, a table is what we use to represent entities in the relational database design. So a table could have 0 or more rows. So 0 means the table is empty, there's no data in it. But it will definitely have columns, even though the number of rows is 0, but it will have some columns, maybe 1 at minimum. Each table has a fixed set of columns. You can define the relationship between tables using primary and foreign keys, as we saw in the data model earlier. And at the same time, you can access the data in your table or tables using SQL. So apart from tables, another structure that is very rampant within a relational database environment is going to be the indexes and views. So what is an index? So this is just a bit of stories that give us an layman understanding of what an index is and how it works. So an index helps you to search for data in your table. Think of an index over a table like an index at the back of a book. A book index contains a sorted set of references with the pages on which each reference occurs. So you want to find a reference to an item in the book, you look it up through the index. So with the index at the back of the book, you know what range of pages to actually go to, and it helps you to save time and get to your destination much quicker than having to go through from the beginning of the book to the extreme end or to where you're going. So back to the SQL environment. In the relational database, when you want to create an index, you need to specify a column in your particular table you are creating that index for. The index contains a copy of the data in a sorted order, and it has pointers to the corresponding rows in the table. So what this is just trying to say is that when the user now runs a query that specifies this particular field or column that you've created an index on using the where clause statements, the DBMS engine now uses this index to fetch the data much quickly than it would have done if it had to go through the entire table row by row. In the example below, the query retrieves all orders for customer C1. So the customer ID is C1. So we want to see how do we leverage index to optimize database query performance. That's just what indexing is all about. So you can see the query being run here. There's a select order ID and product ID from the orders table where the customer ID equals to C1. So if you can see in the middle here, the index is applied on, is created on the customer ID field. So what it does is literally it sorts just that field that you have created the index on. It sorts it by the order ID and the customer ID now, because we created the index on the customer ID field. So it starts from customer 1, customer 2, customer 3 till the last customer ID we have in that table. So when you now try to run the query on the left here, and you say where customer ID equals to C1, because the index is already applied, it knows that, okay, the first 4 rows are what we have as customer ID C1. So it only returns values for the first batch of C1s that it sees. Because going down the table, there's no more C1 in the table. So with the aid of the index on the customer ID field, we're able to actually return data faster from the table. So now looking at a view, which is the third component we'll be looking at. A view is a virtual table that is based on the result set of an SQL query. So in the simplest case, you can think of a view as a window on a specified row in an underlying table or tables. For example, now you could create a view on the orders table that would list orders for a specific product. So in this use case, we are looking at product P1. So we are creating a view called P1 orders. So P1 orders here is the view name. So we are saying create view P1 orders as, then we provide it the result set query that we actually want to see. So we are selecting the orders, the customer ID, the order ID, and the quantity from orders table, where our product ID is P1. On the right here, we have a more complex query, the other one we saw earlier, whereby we've done a join between the 3 tables to give us both customer name, the ordered quantity, and the product name across these 3 tables. Then we want to save these result sets into a view called customers product, so that next tomorrow when we still need this same information, we don't necessarily have to start writing this code again. We can just go query this view and it gives us these data sets. So the next bit here, we want to talk about choosing the right platform for a relational workload. So now over the years, cloud computing has grown in popularity, promising flexibility for enterprises, opportunities to save costs and time, save money, also improving agility and scalability for enterprises. But on the other hand, some organizations still feel very much comfortable running their infrastructure, their software, their applications on premises, on their own servers, within their own firewalls, and having full control over their data and their infrastructure and everything they have in their IT environment. So when you're looking at migrating to cloud or running on premises, you need to put those sort of feed gap analysis. What are the pros and cons? How does this best align with the company policies and all of that? So whether a company places its relational workload in the cloud or whether they decide to keep it on premises, data security will always be paramount. At the same time, for most businesses in highly regulated industry, the decision might already be made for them. So I know that, like in Nigeria, for instance, the government bodies, they really don't want to put their data into cloud environment like Google Cloud Platform, Microsoft Azure. So they prefer to use an home-based cloud environment, which is the Galaxy backbone. Yeah. So they prefer to save their data in such cloud environment they can actually manage than giving it to a third-party cloud provider. So at the same time, knowing that your data is located within your in-house servers and IT infrastructure might provide for some people more peace of mind. So they feel that, oh, at least we are able to ensure that anybody having access to our data, we are the ones giving them the access. It's not in the environment, in a cloud environment whereby somebody can just hack into the cloud provider's infrastructure and the data is at risk. At the same time, a cloud-based approach uses virtual technology to host a company's applications off-site. The good side of cloud environment is there are no capital expenses. You don't necessarily pay for data to be backed up. All of these are managed by the cloud provider. You only have to pay for the resources you use. You pay for facilities and services that you use and consume. So going cloud, there are two approaches. You either go infrastructure as a service, that's IaaS, or you go PaaS, platform as a service. So depending on the environment, depending on your budget and what you're trying to achieve within your business. Infrastructure as a service, Azure gives you that opportunity to create a virtual infrastructure in the cloud that mirrors the way your on-premise data center might be working. So you have the opportunity to create a set of virtual machines, Azure VMs. You could connect them together using a virtual network. You could add a range of virtual devices at the same time. In many ways, this approach is similar to the way in which you run your system, your on-premise architecture. The only thing now is that you don't bother yourself with buying or maintaining the hardware. All of these are virtual machines created on the cloud environment from Microsoft.
And you're
So you are not spending on
what
cost
keyword
for
language is the
purchasing
twist.
licenses
What
or
keyword
servers
language is the examiner
or
using
maybe
to
making
determine if
provisions for
something is
data
true,
center
false,
and
or
all of
not
that.
given?
You're leveraging servers in the cloud environment. For platform as a service,
So go ahead
you want to
and
consider,
stop the lecture right now,
instead of just creating
set
a
a
virtual
45-second clock,
infrastructure and
and see if
establishing
you can find the keywords.
a platform as a service solution actually gives you all of this in a solution at once. So you specify the number of resources that you will require. So it's more like a subscription-based approach. Based on how large you think your databases will grow, the number of users, the performance you require, and Azure automatically creates the necessary virtual machines, the networks, and other devices for you. At the same time, you have the opportunity to scale up or scale down. That's increase or decrease the size of your resources as the number or volume of your data and workload begins to varies. Azure handles this scaling automatically for you, and you don't have to manually add or remove any VMs or maybe perform any form of configuration. So platform as a service helps you to push more of the administrative tasks and routines to the cloud provider. So Microsoft on their end have to do all that for you. You just pay them for their service. They do all the whole thing for you and you're happy. Okay. All right. So before you migrate, you want to do a check and balances to see what are my options, which one is best for my business. So in terms of personal control of your data security, you have full control over that when you are running your infrastructure, your database on premises. But when you put it on cloud, you have to leverage the data security provisioning of Microsoft or your cloud provider. Or when you look at scalability, your on-premises deployments are not scalable. So you are buying a server of maybe 1 TB storage and you begin to use it. Then when the storage is filled up, you then have to start considering buying an upgrade or doing an upgrade to that server, buying more hard disk volumes, mounting more storage partitions and all of that. But when you're on the cloud, it's easy for you to just scale up. You can just go back to the Azure portal, increase this the storage, the disk size, even the computer resource. You can increase the CPU's configuration and all of that. So it's very much flexible for you when you are on cloud. It's more scalable. Hardware maintenance is done strictly by the cloud provider, so you don't worry your head about that. Software maintenance at the same time, Microsoft handles that being the cloud provider. When you talk about low capital expenditure, to get on board on the cloud, you really don't pay much like you would do when you're setting up an on-premises data center or data environment. Because on-premises now you need to buy servers that will last you for a while. But for the cloud, you can just spin up something that will work for your business now. And as the business grows, your data size increases, you can always scale up. But you can't do that. You don't have that privilege when you are working in an on-premises environment. So low operational expenditure. Okay, so when you do on-premises, operational expenditure is quite low, unlike the cloud part of it. So looking at the other chart on the right, we have a capital expenditure and day-to-day control on the y-axis, and on the x-axis, you have the administrative effort. So when you are physically on-premises, you have your SQL server on-premises, on physical machines. Capital expenditure, day-to-day control, administrative efforts are quite high. So they are really on the extreme. But Microsoft has brought up the opportunity for us to leverage infrastructure as a service, whereby you leverage using SQL servers installed on Azure virtual machines. And at the same time, you could even leverage virtualized machines, whereby you reduce the number of physical servers you have, and most of your servers are running virtualized. The next phase to it is the platform as a service, whereby you are using virtualized databases. You don't even need to know about the servers hosting these databases. All you need is just the connection string to that database. A typical example is your managed instance and your Azure SQL DB. So with this platform offerings from Microsoft, you really don't even bother yourself with any infrastructure. You just have a direct connection to your database on cloud. The server hosting the database, you leave that for Microsoft to deal with. Power, troubleshooting, updates, and all of that. Microsoft handles all of that for you. All right, so that brings me to the end of my presentation. I think it's time for questions. If you have any questions, you can ask at this moment. Thank you. Hello, everyone. Are there any questions? Chijoke, I can see your hand is up. Please feel free to ask your question.
Good afternoon. So I wanted to ask,
Sorry,
thanks for the
speaking?
presentation. Please, Chijoke speaking. Can you hear me?
Okay. Yeah, I can hear you.
Okay. Can I go ahead, please?
Yes, please. Please go ahead.
Okay. Yeah. Good afternoon. Thanks for the presentation. So I wanted to ask, you really did a great job. Like it's quite explanatory what you shared on the slides. So what I want to ask now is, are there platforms like easy guides where someone can quickly do demos and try to work with these new platforms?
Yeah, okay. That's a fantastic question. So if I get your question, are you saying an environment whereby you can play around with Azure services, data services basically?
Yes, exactly. Yeah.
Yeah. So there's something Microsoft does on the Azure portal So for new users that currently don't have a subscription on Azure, when you sign up for a free trial account, I think they give you about 200 megabytes of data that helps you to create, utilize Azure resources. I think in a space of a month or thereabouts. So you have that full access to Azure resources. You're able to create a database, test run the database, connect to it, populate it with data, and just get your hands dirty and busy with the Azure data platform as a whole. But basically, what I just explained, my own presentation today is not really focused on the Azure environment now. So we're even looking at, okay, for people that are running relational databases generally, be it SQL Server on premises, be it MySQL, be it Postgre, whichever kind of SQL environment you are running. What are the building blocks of a relational database? That's why we are here today. So you agree with me that the concept of tables, relational data model, views, and indexes, it cuts across all of the OEMs that provide relational database management solutions. It's the same thing in Microsoft, it's the same thing in Oracle, it's the same in MySQL and all of that. So you can actually even install the free version of SQL Server on your local machine. So there's this SQL Server edition called SQL Express. Don't require any license from you. Once you download it from Microsoft websites, you install it on your system. So you now have the SQL Server engine running on your system. So the next thing you need to install would be SQL Server Management Studio. So Management Studio is another application that allows you to then connect to the instance of your database. So if you have databases on your local machine within the Express edition I just talked about, you can query them, you can create a database, play around with it. This has nothing to do with Azure environment at all. It's just locally on your local machine. And at the same time, if you have a database on Azure, you can then leverage using that SQL Server Management Studio application on your system to connect to that database on Azure from your system. So I don't know if that answers your question, Chijioke.
Yeah, it does. Thank you.
All right, you're welcome. Okay, so any other questions?
So
I think we
I
still have
have a
some time.
question. Deleke, or I don't know if I'm getting your name right.
Yeah, Rashid, I can hear you. You're right.
Okay, Mr. Yobami, thank you for the. Okay, let me allow Dr. Bola go first. I saw Dr. Bola raising her hand.
Okay.
Dr. Ibola, you can have the floor, please.
Okay, thank you, Mr. Rashid. Mr. Abam, thank you for this wonderful session. I just want to ask if there are other tools, analytic tools apart from SQL, that can, I know SQL is a powerful tool that can perform the same function SQL is performing. For instance, if I don't want to
Doctor,
use
can you say that
SQL
again? You
for
say
my-
SQL is a powerful tool that can perform the same function SQL is performing. I don't know if I'm
I
getting
said
it
that
right.
there are other tools, analytic tools that one can use apart from SQL to perform an analysis that SQL could also do. Because I see a lot of people using SQL, but are there other analytic tools that one can use aside SQL to perform transformations and all of that?
Yes, good
We are
question.
talking about relational database management, something. Are there other tools that one can use apart from SQL?
Yeah, so to answer your question, SQL is the standard query language for a relational database. So when you are coming into a database to access data, query data, you don't have any option. You have to just use SQL. There's no alternative to it. It has to be SQL. But when you now say you want to analyze data that is stored in SQL, yes, there are a number of applications. You can import data from SQL into Excel. You could import it into Power BI, then use different tools different BI tools, Excel, Power BI, Tableau, and all of this to then analyze your data. But if it comes to you querying data or populating data into a database, you don't have any option than to use SQL.
All right. That's cool. Thank you.
You're welcome.
I think maybe let me tip in. I don't know, but let me just try. You know, a part of MySQL, I think we have PostgreSQL. We have some other probably organizational
Yeah,
SQL that
other
are
OEMs.
different from Microsoft's.
Exactly.
But if you're a Microsoft evangelist, of course, you must stick to TSQL. You know. So
Yeah.
my own question is, this platform as a structure and infrastructure as a structure that you mentioned in the course of your presentation. So
Okay.
for me, I just want you to throw more lights. I want to have more understanding about it.
Okay.
Because
So infrastructure as a service is you leveraging cloud infrastructure. So ideally, in a business, many years back when IT was just starting and evolving, you used to see that organizations will have a server room. Inside that server room, there will be physical servers, fully ventilated with ACs and all of that. Then there will be somebody in charge of the server that is ensuring that, okay, people can actually log into the server. There's a database administrator that ensures that, oh, the disks for the servers are accessible and people can actually connect to these databases within the business. So as things have evolved over time now, Microsoft has come up with infrastructure as a service whereby you don't need to necessarily spend money buying physical servers or setting up a physical server room within your organization. So instead of having a physical server room, all your servers will be on Microsoft Azure environment. That's the cloud environment for Microsoft. So what you just do is using your Azure subscription on portal.azure.com, you create a virtual machine, a VM on Azure. You assign it a server name, an IP. You install all of your business applications on it. All your solutions are running on that server, on that system. It might not be one, it could be 20 servers depending on the size of your organization, all of them running on Microsoft Azure Cloud. So physically, when people come into your organization, they will not see a server room. But you know that you as the IT guy, you know that, oh, all your servers are running on cloud. So all you just need to do is have a server, a physical system. It could even be your personal laptop. With that server system, you can then do remote desktop access to your cloud servers and manage your business on the Azure environment. So you can do a remote desktop to your servers, set up users, set up applications, build up your reports, and do everything you would do on a conventional physical infrastructure. Then for the platform as a service offerings when it comes to data is majorly on the database layer. So what differentiates it is this, that ideally for you to have a database server, you need to have first have a physical server. Then on that server, you install SQL Server on it. Then you create a database. But now Microsoft has gone platform as a service whereby you could just spin up a database directly on Azure. So you're not even interested in knowing which server is that database hosted on. It's none of your business. Microsoft is going to handle that. So you just need to know, oh, I created a database called sales database on Azure. This is the username to log into that server database. And once you have that information from your local machine, which is your personal computer now, if you have SQL Server Management Studio installed on it, you can then connect to that database on Azure from SSMS. So that's just the idea of infrastructure as a service and platform as a service. So it helps you to save cost on buying physical infrastructure. You don't have to buy a physical server, then now pay for money to buy SQL Server license, then before you now start setting up the databases and all of that.
So thank you. Thank you. Before Larry speaks, please. One more thing is that a lot of company in Nigeria that I know, even my organization that I work for, still uses servers that you can cite. We have a server room, but a lot of companies are now migrating to the cloud. Does it mean that cloud migration has a competitive edge, or is just spontaneous thing? People just feel okay, they are going to cloud. Let me to go to cloud. I want to have a better understanding why companies are migrating to the cloud now. Why cloud has become the in thing.
Yeah, so to answer that, looking at it from cost perspective, majority of the organizations will prefer cloud because why? It's relatively cheaper. So let me give a scenario now. So if you have a physical data center in your organization where you have your servers. Remember, these servers you bought them maybe some 5-10 years ago. As business is expanding, the storage volumes on these servers are getting filled up. So the next time, maybe there's a server that you use for your customer information, and the TB, the storage is 1 TB, and now your data is hitting 1 TB. It's already getting full, and you have to find a way to increase that storage capacity. For the on-premise, what comes to mind is, oh, we need to buy additional storage, and the additional storage you are buying now is quite going to be expensive because you don't want to buy a size that is small. You want to buy something that will last you for another maybe 10 years, depending. So you are paying for 10, let me say another 1 TB or 2 TB storage size. You are buying that hard disk drive, physical drive now, to be mounted on the server. But if you are going cloud, in the cloud approach, you don't necessarily need to buy 1 TB or 10 TB storage at once. You can actually even buy 1 GB storage, or set up one, not even buy now. You're setting up, is a setup. So you set up a server with 1 TB storage, and as business grows, your data grows. Maybe next week you see that, oh, we're almost eating 1 TB. You just go back to Azure portal and scale up that storage size to become 2 TB. And the good thing again about it is that on the cloud environment, you only pay for what you use. So you're only paying for the volume of data you are storing. You're not paying for the entire data and the entire infrastructure. You get my question? Then that's in terms of storage and cost. So in terms of administrative efforts now, when you have your servers on cloud, you don't necessarily need to have maybe 5 DBAs that you need a physical office, or maybe you have a data center in Lagos, you have a DBA for that Lagos data center, you have one in Abuja, you also need one IT guy to be managing that. If they are all on cloud, it saves you cost because you only need one person to just log on to the Azure portal and do a remote desktop across all of the servers and ensure that they are all running fine. So from one location, one person can actually be administering and managing all of your infrastructure on cloud.
So thank you so much. So let me talk like a bushman now. I don't want to talk like somebody who is not a local man.
Okay.
I'm seeing my server, and I know that it's safe. In the cloud, can't the thing go missing?
Well, so that's the good thing about Microsoft. When you are setting up resources and all of that, there's this SLA that Microsoft gives to you that ensures that, okay, in a situation whereby the region you are working, you have your data hosted on, when maybe that region goes down, there's a backup. Your data is there's what they call what's the word now? Geological replication of data. So your data, on Azure, you operate based on region. So you deploy your resources and infrastructure and all of those resources you are creating on Azure to a particular region. But Microsoft Azure has what you call availability groups and availability sets, whereby, so if a particular region is down, there's like a backup of that region in another region. So if that particular region you have your data at that moment has a challenge, based on their SLA, I think it's usually about 99.993% availability assignments and all of that. So once that particular region you have your data is down, you will not even notice. They automatically cut over to the other region. So it's something that they always manage for you. You don't have to worry your head about that.
Okay,
I don't know
thank
if
you.
that answers you.
Yeah, I'm fine. Mr. Larry, let's have you, please. Thank you.
Okay.
All
Hello.
right, you're welcome.
Well done. You've been doing a great job all along.
Thank you.
I just want to clarify some. I don't. Okay, let me say I want to shed light more on what to speak before the DB, the going to the cloud issue, the MySQL.
Okay.
We have a lot of SQL. It's not just SQL. Talking about the cloud now, I'm aware that Google has its own SQL, which is BigQuery. For Microsoft,
Yeah.
we have Microsoft Azure DB. We have for Amazon too, they have their own. I think it's Dynamo something. I'm not sure. If just Google itself has Cloud Spanner, has Cloud SQL, and has BigQuery. So I just want to clarify that we have a lot of platforms in which you can run your SQLs. And we have many others too. Oracle has their own, IBM has their own. So there are a lot. Just go online and check out. You have a lot of platforms in which you can run your SQL, aside the MySQL or MySQL. Then talking about the cloud, I think I need to be fair. I'm very sure most organizations prefer to use hybrid. They have part of their functions in the cloud and part of it on in their organization, which I will refer to as what do we call it?
On-prem.
Site, on-prem. Yeah, exactly, on-prem. So most of the ones they put on cloud, maybe like jobs which they know they need scalability, availability, hardware, and many other resources that need upgrade. It is easy for them for the cloud providers to do that for them. But when we are talking about security, like having some sensitive document or sensitive operations, it is normally left on-prem, because we all know when you are inside the cloud, though we are very sure it is secured, but to some extent, it is not 100% secured. We all know that it is not 100% secured. So part of it is on-prem, while part of it is on cloud. So most organizations use hybrid. So I think hybrid is the best. So I just want to share. That's what I want to pass on.
Yeah, thank you, Larry, for that.
Thank you so much for that contribution. I appreciate it.
Thank you. Okay, any other questions?
Who is our moderator?
Emmanuel is our moderator for today. Emmanuel, what do you have for the house?
Emmanuel, what do you have for us?
Emmanuel,
Uncle Larry. Uncle Larry.
Dr. Ebola is raising up her hand.
No hand is up. Oh.
Hello?
I'm seeing one hand. Doctor, are you raising up your hand?
No, I'm not. I'll put it down.
Okay.
Hello?
Yeah, Aladimiji, are you speaking?
Yeah, Mr. Sheyi, yes. Mr. Sheyi, Mr. Larry, well done. I'm just joining the meeting, and I knew that I must have missed a lot. So I don't know if we have on record, if I can still check it out on YouTube or something.
Oh yeah, sure. So I think the team in charge of publishing and updating it on the YouTube channel will take it up after the close of this session. So yeah, I think it takes about 2 days max, and it will be shared on the WhatsApp group. Are you on the WhatsApp group for the community?
Of course I am.
Okay. So you'll get a notification once it has been uploaded on the channel.
Okay.
All right. Yeah. Okay. So we have a minute to go. So I think next week we should have a session on going deeper into Azure Data Services. I think Paul Barnabas will be anchoring that session. So it's going to be another interesting edition. Let's do well to attend. And I also want to thank the very few one of us that could make it to the session today, although attendance seems to be a bit poor today, but it's okay. We can do better. I know we can actually do better. So let's encourage ourselves, our friends, to make it a date with us same time next week. So from my end, I want to once again thank you all for your time. It was nice sharing my weekend with you all. Hello.
Yeah, there are some Nigerians that want to join this group, but they are not in Nigeria anyway. So I don't know if I can share the link for them to join the meeting against next week.
Sure, you can.
They are not Nigerian, but they are nice people, so they are professional.
This is Microsoft Africa Data and AI. So we are not just restricting ourselves to Nigerians. We are open to the whole world. So you are free to share the invite with them. Let them join the community.
Okay.
And learn from us. Right. So welcome, my dear. Thank you so much, Winga. All right. I think at this junction we can call it a day. I really appreciate everyone. Do have a nice weekend. Bye.
Thank you so much, Mr. Yoba. Adeleke, thank you so much.
Yeah, thank you, Rashid.
Mr. Larry, are you there? Mr. Larry. Hello, Mr. Larry.
Hello, Larry. I will share the link shortly. I saw your message. Apologies.
Okay.
Yeah.